Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. All right, Chapter 6.2, Modeling Tax Schedules. All right, so brand new background today. I was out walking this morning, and this is a picture of Mount Etna in Sicily, and it just looked magnificent this morning. So there's a new photo. Flat tax. Flat tax is simply a tax where the percent does not change. So if you go into a grocery store, let's say in the state of New York, depends on what county, then it would be, say, 7% sales tax. You buy $100 worth of items, you'll pay $7. You buy $1,000 worth of items, you pay $70. No matter how much you purchase, the tax rate stays the same. That is a flat tax. A proportional tax is also a tax that does not change. So proportional tax or flat tax are basically the same thing. But then we get to progressive tax system. And we use a progressive tax system in the United States for our income tax. Federal income taxes are progressive. The more money you make, the higher your taxes become because of the tax brackets. So in example 1, if you look down here, you'll see a schedule Y-1, and as your pay increases, your taxable rate goes from 10 all the way up to 39.6%, depending on how much you make. That is a progressive tax system. And the tax bracket is a minimum maximum amount. So for example, if you were in the 28% tax bracket, it means you make at least $151,200, but no more than $230,450. And so you'd be in that bracket, okay? And then regressive tax schedule is a tax schedule where the more you make, the less percent, by percent gets taken out. So the more you make, the less you pay in. Okay, so all kinds of debates on what type of tax system we should use. And here we go. Example 1, model taxable income columns in schedule Y-1 using tax schedule notation, interval notation, and compound inequality notation. So they want us to model this using tax schedule notation, interval, and compound. That's all they're asking us to do here. So just to save time, I brought it in from a clip. And tax schedule notation is just simply this. So the tax schedule notation is basically this right here. Okay, so if I were to get rid of this box or change its shape, let's say, and move this over like so, all this says is over 0, but not over this. Over this, but not over this, and that's all you keep repeating. That is tax schedule notation. All right, compound inequality notation simply means you have 2 inequalities or more. That's what compound means. So for something over 0, but not over 18,450, what you would say is x is greater than 0. And x is less than or equal to $18,450. So that would be a compound inequality notation because it says and you have 2 different inequalities. Putting these in the proper order, so putting x in the middle. So if I have x is less than 0, well, that's the same as flipping it around and saying 0. I'm sorry, x is greater than 0. That'd be the same as flipping around and saying 0 is less than x. So x is greater than 0. Okay, x is greater than 0 is the same as saying 0 is less than x. Okay, these mean the same thing. And then when you do that, and then you put together with the word and, x is less than or equal to $18,450. So all we're doing is we're taking this first one, putting the 0 first, flipping the inequality, putting the x on the other side. And then when I erase the word and we don't need x more than once, it leaves us with this. And then we squeeze it together. And that's how we get x between 0 and 18,450, but including with the equal sign. Okay, so that's interval notation. All righty, so there you have it. We just need to do that for every single one of these. And so as I go, so over 18,450 is x is greater than 18,450 and x is less than 74,900 or equal. Interval notation just flips this first part so that X is on this side, get rid of the word and the extra X. And we have 18,450 is less than X is less than or equal to 74,900. And I'm not going to take any more time to explain this. I'll just slide this down like so, or actually get rid of it. And we just keep doing that. And so this is the solution to number 1. Okay, and over 464,850, it's not a compound inequality in that situation. It's just a regular inequality. X is greater than that. Interval notation is the same when you don't have an interval. Okay, so it says write the tax schedule notation, compounded inequality notation, and interval notation that would apply to an income of $172,876.99. So to do that, okay, so what I'm going to do here is I'm just going to create a box and I'll make it red. And so where is 172,000? Well, it's more than 151, but it's less than 230. So 172 is in this interval right here. Oops, I picked the wrong idea here. So let me switch this. So if I go to box like so, and go like this and line color red, not fill color. So 172,000 is more than 151, but less than 230. So we would be using this bracket. Okay, so that would mean the answer was our inequality notation. Well, I should first start with write the tax schedule notation, and that would be over $151,200, but not over $230,450. The compound inequality notation would be X is greater than 151,200 and X is less than or equal to 230,450. And finally, interval notation would be 151,200 is less than X is less than or equal to $230,450. So it's just this one row, which is the tax bracket. Okay. Okay, section 2 or example 2. Example 2 says, how does a piecewise function relate to the tax computation worksheet? So part of the solution is to examine the section B tax computation worksheet for married taxpayers filing jointly. I have the schedule Y-1 from example 1, and notice the intervals. So over 74,900, this came from actually the textbook. It was page 430 or 342. This came from page 342. This table right here. So they gave a tax schedule notation and they gave a tax equation. And then notice here it says over 74,900, but not over 151,200. But then if I come down here, it says 74,151,200 in the schedule Y-1 for example 1. But now that we're on example 2, they gave this section B, and now it says at least 100,000. So I'm not sure what happened with the 25,100 here. They jumped up to 100,000, but not over 151,200. So we're just going to use this because this is what was given in the book. And we're focusing on this column subtraction amount D. And where do these values come from? Well, they come from this right here, this equation. So if we're going to calculate at least 100,000, but that should be actually 74,900, I believe. How did they get this value here? Well, if we look up to here and over 74, but not over 151, where did this dollar amount come from? So if I look at this Y equals, I'm going to write it over here. If I write Y equals $10,312.50 plus 0.25 times X minus $74,900. And if I distribute this 25%, then I'm going to get $10,312.50 plus 0.25x minus, and then when I take 74,900, 749 times 0.25, I'm distributing that quarter, it's 18,725. Okay, so then when I combine like terms, this and this, then I'm going to get $10,312.50 minus 18,725. Okay, and that is going to give me negative 8,412.50. So it's going to be y equals 0.25x minus $8,412.50. So as you can see, my constant in this equation is that value that we're subtracting from that multiple for the next bracket. And that's where these values come from. Where did 12,948.50 come from? By plugging in or distributing this 0.28 here and subtracting this from this. That's where that came from. Okay, so that's all they did there. You do the linear equation, do the distributive property, and the value you get, y the equal, is the amount you're subtracting from D. Okay, it's the constant in your linear equation. It's your B. Okay, and so that's example 2. So now check your understanding says the tax equation for income over 230,450, but not over 411,500 is this equation right here. So they're taking the line above. So now what they're talking about is, since we're over 230 but under 411, we're going to go to this row here. And there's the equation. It says simplify the equation and explain the numerical significance of the slope of the y and the y-intercept. So if we're going to do that, we're going to take y equals $51,577.50 plus, and I'm just going to distribute here, 0.33x minus, and then I'm going to take 230,450, multiply it by 0.33, which is dividing by 3, and I get 76,048.5. 76,048.50. Combining these two terms here, my constant values, I'm going to get y equals 0.33x minus, and I'm going to take 51,577.5 minus 76,048.50, and I get 24,471. Okay, and there it is right there. So now it says, what does your slope represent? So m equals 0.33. So that means you're in the 33% tax bracket. You're paying 33% tax on the tax that is over 230,000, but not over 411. You're paying less amount, which is this amount here. This is actually the 10% plus the, if you go up here, it's the 10% for the first 18,450, and then it's 15% of this fraction, 25% of this amount in this bracket, 28% of this, and then finally 33% of that over. So you're paying the pieces of percent, and that's what these formulas are calculating. You don't just pay 33% of everything. You're only paying 33% of it in over 230. You're still paying 28% over this, and you're still paying 25% over this, and 10% over the first $18,450. Okay, what does the B mean in this equation? What's the negative 24,471? Well, that $24,471 is the amount of tax that was charged that would be more than the 33%. So we're charging 33% in this bracket. You don't want to charge 33% to this, or this. So this amount here is the 10% up to 18, which would be the 8,000 plus the 12,000 plus the 1,845. Okay, so let's just check that. So what is 24,471? So if I take $24,471 and I subtract the prior tax amount, which was let's see, 10,312. $50. I'm down to $14,158. Subtract the $1,845, and that's going to get me down to $12,313. And these are the tax amounts that are figured in that's already been taxed. So 10% of 18,450 is $1,845. 15% of 74,900 minus 18,450. So if I took $74,900 minus the 18,450, the difference is $56,450, and I'm going to pay 25% of that. And that's 14,112. And then what percent I pay. So it's all these values added up that will give us this $24,471. They don't want to tax us again. That's the difference of the tax brackets, the 28%, the 25%, the 10%. Okay. All right, example 3 just asks us to express the equations in the married taxpayers filing jointly schedule in a y equals mx plus b form, a linear form. Okay, so this one's already done. So this would be y equals 0.10x. And if you wanted to be technical, it's plus 0, b is 0. In this one here, we'll need to distribute, so we'll do these down below. So y equals $1,845 plus 0.15x minus, and then I take 18,450 times that 0.15. I'm distributing the percent, and that gives us 2,767.50. And then when I simplify, 1,845, so we're going to get 0.15x minus the difference of this constant and this. 1,845 minus 2,767.5, okay? And when I do that, I get negative 922.50, so that's 922.50. Okay, so I'll put that here. Y equals 0.15x minus 922.50. Okay, we keep doing this. I'll just change colors every time. Y equals, and now I'm doing the third one, 10,312.50 plus 0.25x minus, I'm distributing now here. And then I take 74,900 divided by 4 or times 0.25, 74,900 times 0.25 equals 18,725. Okay, and that is going to give us y equals 0.25x minus. And I have this 18,725. It is negative, so I could say times -1 just to not confuse you. So now it's negative 18,725. I will add 10,312.50 to it. And I get negative 84,12.50. So my y equals 0.25x minus 8,412.50. Okay, next one, this one here, y equals $29,387.50 plus distribute the 28%. I get 0.28x minus, and I take 74,900 times 0.28, and I get 20972. Okay, go back on my calculator. I'm just going to say times -1 to make that a negative 20972 and add 29,387.50 to it. Is that correct? I think I wrote something down wrong. 28. No, it's 151. I made a mistake there. Let me fix that. As soon as I saw I wasn't going to get a negative number, I knew I did something wrong. I want to take 0.28 times 151,200. I did 74.9 again. Okay, so 151,200. Always check to see if your answer makes sense, and if not, fix it. Times 0.28. Enter. There we go. 42,336. That number should always be less than that other number here. So then I'm going to multiply that by -1 and add 29,387.50. I get -12,948.50. So y is going to equal 0.28x minus 12,948.50. Okay, so y equals 0.28x minus $12,948.50. Okay, the next one I'll do in purple. Y equals $51,577.50 plus 0.33, 33% of x. Let's just do the distribution here. 0.33x minus 230,450. 230,450 times 0.33 gives me 76,048.50. So I'm going to get this 0.33x minus the difference of 51 and 76. So multiply this by -1 just to change its sign. And then add 51,577 to it. Oh, I forgot the 50 cents. Plus 50 cents is 24,471. So my answer is y equals 0.33x minus $24,471. Right. Next one I'll do in black. Y equals 111,234 plus 0.35x minus and 411.5 times 0.35 equals 144,025. Okay, so we're going to get y equals 0.35x minus, take that 144,025, make it negative, and add a 111,234. And that will give me 32,971. So my y equals 0.35x minus 32,971. Okay, and finally the last one I'll do in red. It's this one here. Y equals 129,96996.50 plus 39.6% times x minus, and then I take that 464,850 times 0.396, enter, and I get 184,080. 184,080.60. Did I do that right? Got 60 cents. Yeah, that's right. Okay, so now we're going to get y equals 0.396x minus, take that 184,080.60, make it negative by multiplying by -1, and then add 129,996.50, and I get negative 54,084.10. So it's y equals 0.396x minus 54,084.10. Okay, so there is example 3. Now check your understanding, pause the video, see if you can do this. It says use the appropriate equation from example 3 to determine the tax for an income of $46,000. Let me move this up so we can see it, and move this up so we can see our table. And so the first thing you want to do is determine which bracket you're in. $46,000 is going to be, let's go back to our table. 46,000 is over 18, but less than 74. So it's the $1,845 equation. So it's this one, which became this one. So we're going to write y equals 0.15x minus $922.50. So my x is my taxable income, my y is the tax I pay. So it's going to be 0.15 times 46,000 minus $922.50. So I get my calculator, 0.15 times 46,000, and I get $6,900 minus $922.50, and that will be my tax. So it's minus 922.50, and I get $5,977.50. Okay, that is the tax for an income of 46,000. All right, example 4, it says to examine the piecewise function f of x composed of the first 3 equations in example 3. So they gave us 0.10x when x is less than 18,450, 15% of x minus the 922.50, which we just calculated, between 18,450 and 74,900, and 25% of your taxable income minus this 8,412.50 for the bracket between $74,900 and $151,200. Graph the function on the appropriate interval. So I'm going to get my graphing calculator. Okay, and we're going to go to y equals and make sure everything is cleared out of there. I will just simply put this function in. Okay, so the way you want to do this is put the equation. So I want to put in parentheses 0.10x parentheses, and then another parentheses, and then x, and then there's greater than, less than, and it is, you press second first, then math, and there's your logic. And the greater than is 3, so I can just press 3 if I want. So now it says x is greater than 0. And then I put second math. I want the word and. go over to logic, and it's number 1. So I'm saying use this equation when x is greater than 0 and x is less than or equal to x second math less than or equal to is 6, and my upper parameter is 18,450, like so. Now if I graph that, my interval is from 0 to 10. So I'm seeing it, but not much of it. I will change the window after. So let's go back to y equals and go down to the next equation. And what we do is we put this in parentheses. So again, parentheses, 0.15x minus 922.50. Close the parentheses, and then you give it the parameters. And then you'd say 1,800,450 second math. Actually, I want it greater than. So let me delete those. Let me go back. I want to do the x first. You always do the x first. You want x is going to be greater than 18,450. So x second math 3 for greater than 18,450. Okay, and then I want to say and, so that's second math arrow over to logic. It's 1. Second, no, not second yet. I want to put my parameter in. So then I want to say x is second math less than or equal to is 6. And I want it less than or equal to 74,900. Close the parentheses, hit graph. I'm just doing this so I check to see if there's an error. If it did it and didn't say error, it should be okay. And then go back to y equals again, go to the third parameter. In the first parentheses goes this equation, 0.25x minus $8,412.50. Close the parentheses, new parentheses, x second math less than or greater than is 3. We want x greater than our low bound, 74,900, 74,900. And then we do second math, arrow over to logic, and second math 6 for less than or equal to, and 151,200, 151,200, enter, graph. Okay, I know I forgot my parentheses on that, so I'm going to go to it. And I forgot to close my parentheses. I think that's all I did wrong there. 151,200x 74. Yep. Now if I hit graph, I should not get that error. Okay, we're good on the first one. We're good on the second one. No, still an error. Go to. So let me see if I can figure this out off screen. One moment. Okay, so I found it. After I said and, I didn't put the variable. So I want the variable here. So I'm going to hit second insert. And I'm going to put an X. And now hit graph. I forgot to put my variable X less than or equal. I just put and less than or equal to. I forgot my X. So hopefully this doesn't give me an error now. And very good. Okay, so now I want to adjust the window. So we have to think about this. Looking at this, we want our X minimum to be 0. We want to go down to $0. We don't ever pay, we don't get paid tax. Well, we get tax return, but let's make this 0. And our X maximum is going to be something greater than this 151,000. So let's just make it 160,000, just so we're seeing the whole screen. And then our scale being 1 is going to be way too small. So let's make the scale, the book suggests, we can mess around with this, but let's make the scale 20,000. That means every one would be 20,000 because we're going so large. So make that 20,000. Y minimum is going to be 0. We don't want negatives. And the Y maximum is going to be our maximum tax, which let's do $35,000. Okay, and the Y scale, let's make it 5,000. So that's adjusting your scale. Then when we hit graph, notice how there's a pause there, and it's really hard to see, but what this really is a linear equation that went from here to here with one slope or rate of change. And then there is a slope or rate of change, or the tax rate increase to this point, and then it increased even more. So the steeper the line, the more you're paying in a percentage of taxes. So there is the graph, and the book does have a graph. Okay, so here's a better picture of the graph. So from 0 to 18,450, this was a tax rate. And then from 18,450 to 74,900 on the x-axis, because we don't see our intervals here. So remember, we made this one, what, 50,000 or 20,000. So this is 20,000, 40, 60, 80. So 74,900 is just before 80. Here's 100, here's 120, here's 140, and 151 is before 160. So that's why we chose these values. And this is 5,000, 10, 20, 30, 40, $50,000 in paying taxes. So as you can see, this is approximately $30,000 in taxes on $151,200 worth of income. Okay, so now let's check your understanding. If you were to graph the fourth equation in the piecewise function, y equals 0.28x minus $12,948.50, where would you expect the last point in that equation to be, and explain your reasoning? Okay, so looking at this, we're in the 28% bracket minus the 12,000. So I'm going to go back a couple of pages, and that would be in this table right here. So our maximum income is $230,450, $230,450. That is our taxable income X. So it's $230,450. Let me make sure I wrote that down right. $230,450, yes. So the maximum point X would be $230,450. I don't want to close my parentheses there. I want a point X comma Y. So then I'd put a Y in here, and what tax would I pay on $230,450? Let me put the comma for the XY in a different color so we're not confused by these two numbers. And so then when I put that in my calculator, I would put 0.28. I'm putting the equation with this X, $230,450. And it's going to be minus $12,948.50. And when I do that, what happened? Oh, I don't need a parentheses there. Delete, enter. I get $51,577.50. So that will be my Y. $51,577.50. What does that mean? It means I made $230,000 and $230,450, and I paid $51,577.50 in tax. Okay, so that's how you would do that problem. Now there's an extend your understanding. What are the monetary implications of the fact that the slope of the last segment of the piecewise function is greater than the slope of the segment preceding it? Okay, so that's a pretty straightforward question. It's pretty easy. The answer is the more income you make, the higher a percentage of it you pay in taxes. Okay, and that is what your slope is the amount of tax percent you pay. Okay, so that's the end of chapter 6.2. Go do your assignment.